This video is on ionic equation and how we write ionic equation. So let's get started. Basically, ionic equation tells us ions that are involved in the formation of products. Okay, so basically, what are the ions that are involved in forming a product? Okay, so how do we do it? You start with your basic equation. So this is an acid-alkaline reaction, form salt and water. So the first thing that you do is you write down the state symbols, and this is found in the other video, something that you can do. Okay, now let's look at the state symbols. The equations are balanced, state symbols are down. Okay, in an ionic equation, the aqueous product, the aqueous reactants and product will all break up into their free ions, and this is what you get. Water is a liquid and it's not aqueous, it doesn't break up into ions. It remains as a water molecule. So now let's look at the ions, and ions that are present on both sides of the equation, we cancel that away. Sodium cancel that away. And then what we have is H plus and OH minus. These are ions that remains that are responsible for the formation of water. So this is what you have. This is known as an ionic equation. Next we have a precipitation reaction with silver nitrate and sodium chloride. So what happens is a precipitate of silver chloride will form. Okay, so check. Equations are balanced, state symbols written down. AgCl is solid, it's insoluble, so they break up, and this is what you get. Okay, you can pause the video and cancel the ions that are present on both sides. So sodium, nitrate. What is left is silver, chloride, AgCl minus. So the ionic equation will be Ag plus, Cl minus, and AgCl. Okay, another precipitation reaction. State symbols. Now in this case, copper sulfate, Cu2 plus, SO4 minus, copper chloride. So what do we do if we have two chlorine ions? We don't write Cl2 minus. This is how we represent it. We put a number in front. Ba2 plus, 2Cl minus, copper. So basically the chloride ions will cancel off each other nicely. If you have 2 here and 1 there, it means your equation is not balanced, or you have forgotten to put the 2 down. So what else can we cancel? Copper, and this is what is left of the ionic equation. This is a reaction with sodium carbonate and acid, form salt, water and carbon dioxide. In this case, this is a group 1 carbonate, so it is soluble. Break it up, and this is what we get. Now we check. Something doesn't seem right. There is sodium, 2 sodium ions. So how do we write it? Put a 2 in front. 2. Hydrogen has 2. Okay, sulfate has 1, so we cancel the sulfate, cancel the sodium, and this is what we have left. How about water and carbon dioxide? Water and carbon dioxide are not aqueous. One is a liquid, one is a gas, so it remains as it is. Notice that when we have broken up the ions, we write down the state symbol based on what we have. Aqueous. Okay, now that you have understood how to write an ionic equation and ionic equation, this is what you need to take note. Calcium hydroxide, when you break it up, it will be Ca2 plus, 2OH minus. 2 is in front, not below. FeCl3, Fe3 plus, and 3Cl minus. The charge has not increased, it is 1. CH4, NH4, 2, ammonium has 2, and aluminium, in this case Al2SO4 3, 2 aluminium, 3 sulfate. When you get a balanced equation, example 2HCl or 2NaOH, the gameplay is the same. First, put down the ion. Next, put in the number. So in this case, it's like an expansion in maths. 2H, 2Cl, 2H plus, 2Cl minus. Similarly, it's the same, 2Na plus and 2OH minus.